So let's talk more about recursion. Let me do view and get presentation mode. Cool. So what is the idea of recursion? Somebody explain to me. A function that calls itself, right? How can you call, right, the same function? Well, we call it with a slightly easier problem, right? Until eventually we get to a really easy problem that we know how to solve, and the function can just return the value. Does that idea make sense? Cool. So let's play more with some of those things. Let's, one, I like covering recursion at the beginning because to me it is fundamental. It is part of calling functions that call each other, right? And so it is good to cover it at the beginning as opposed to an advanced topic. It's not advanced, it's normal. You're just calling functions, right? But one problem is that we haven't seen many things, so it is hard to come up with good examples, just because we don't have that much. So all of the examples we did last time were basically counting, right? Now, one thing that we can do is define recursive data structures over strings. We have seen strings, right? And so if we think about it, we can define a function is empty that returns true if this string is empty. How can we check if a string is empty? Well, we could do it several different ways. One of them is check whether the length is 0. What other things could we do?
First character is 0. There is nothing in the first character.
But if we call char at of 0, it would actually raise an exception. But what other methods we have on strings? We can compare two strings with which method? Dot equals, right? So we can compare it with the empty string and see if they are the same, right? That would be another way of doing it. And then we can define a string and think of a string as two pieces. It's either the empty string or it has two pieces. The two pieces are the first character and then the rest, the string minus the first character. Does that make sense? I'm calling those two things head, and the head is just the first character, and tail, and the tail is the string minus the first character. So head is just char at of 0, and tail is just substring. Does that make sense? And if we call these things, if we print head of ABC, what do we expect to get? A. And tail of ABC, we expect to get BC, and we are concatenating D. So what do we expect to get? BCD, right? And somewhere we should be able to run. Run Shift F10. Okay. A and BCD. Woohoo! Isn't this cool? And so we can combine characters and strings back into strings with the plus operator. Does that idea make sense? So now we can do recursion on strings by calling head and tail. And our base case is almost always whether the string is empty. So we can define a function contains that would return whether the string S contains the character C. I think we did it last class by iterating over all the elements of the string, right? By counting all the elements in the string. But now, what would it look like? What's our easy thing? What's the easy case? What's the simplest possible string you can think of? One? A one-character string. Okay, that's fairly simple. Can we think of an even simpler one?
No.
It's not null. It's the empty string, which is different, right? The empty string is the simplest one, right? So, if the string is the empty string, what do we return? False. You don't contain the character, right? Does that make sense? Now, what else can we do, right? Imagine that the only things you can do on a string is check whether they're empty, get the head or get the tail, get the first character or get the rest. So what can we do? Get the first character, and then how does that help us check whether the string contains a given character or not? We're not using char hat, we're using head, right? But that's the first character.
You could do char hat, like location, like char hat.
We're using head to get the
Okay.
first character only,
Gotcha.
right? But when would that help?
If length is greater than 1, then we will check.
We're going to check the first character, but what are we going to do with it once we get that first character?
You're gonna add to the character you
I'm going to compare it to the character I'm looking for, right?
Oh, okay.
And if they are the same, what do I return? True, right? Does that make sense? How do I write it? If head of S, that's the first character, right? Equals C. Is C a good name? Should I call it something like target? Then what do I return? True. Right? That is cool. Now, if the first character wasn't it, do I know whether the string contains the character or not? Not yet. What could happen? It may or may not be where? In the other characters, right? Does that make sense? The characters other than the first character, right? How can I get the characters other than the first character? We have a function called tail, right? So I'm going to do stuff with tail of S. What kind of stuff? What I need to do is go find out whether that tail contains the character, right? How can I do that?
Define a head for the rest of the string.
If tail is equal,
Tail is the rest of the string, right?
You can do the head for tails.
you can put the recursion of the.
Yes, I just need to find a function, right, that tells me whether a character is in a string. Oh, I happen to have such a function. What's its name? Contains, because I'm just defining it, right? Isn't this cool? Yes? No? Maybe? Can you
Not yet.
vocalize your questions?
Not yet.
Does that idea make sense?
So we don't need else.
You can put them. We are returning, so we don't really need the else's. If you like them, we can put them. It's the exact same thing, right?
Then it will be clear.
Sorry?
Then it will be clear.
Is it better for you to do else's? Okay, then let's do else's. Why not? You don't need them, right? Returning is returning. You're out of the function. You're done. But
Can you explain the last sentence, return contains?
okay, we know that it's not the first character, right? So imagine that your string is A, B, C, D, and your character is D. We know that A is not D. So now what you need to do is go find it in the rest of the string, in B, C, D, and see whether it's there or not, right? Tail of S would return the string minus the first character, right? Imagine a snake, the head and the tail, right? So tail returns the string minus the first character. And so we just check whether the rest of the string contains the character. And we do that by calling that contains function that somebody else nicely defined for us. Well, that we nicely define for ourselves. Does that idea make sense? Now let's complicate it a little bit. Let's count, instead of just saying true or false, actually first, let's call this thing, right? So what do we expect to get? True and false, right? Yay! So, rather than return whether the string contains a character or not, we're going to return how many times the character appears. Possibly 0, possibly more than 0. Does that make sense? So, how can we do that? Again, what's the simplest possible string? Empty, right? So if the string is empty, what do we return? How many times does a character appear there? 0, right? We're going to check this, and then let me, for now, leave this open. If it wasn't there, what do we return?
Do the same repairs.
We are going to return, right, however many are in the rest, right? Does this make sense? Now, if the character is the one on the head, what do we want to return? Is this okay?
No.
Because there may be more on the rest, right? So how many do I need to return? 1 plus however many are there in the rest, right? How can I know how many were in the rest? Oh, I have this really nice function.
Okay.
Isn't this cool? Oops. Here I called it C rather than that. Does this make sense? and we should get 1 and 0, right? Yay. Does this idea make sense? Cool. How do we reverse a string? Sorry. How can we reverse a string? Again, let's go with the simple case, right? If the string is the empty string, what's that string reversed? Sorry? Not the space, the empty string. Keep in mind, right, the empty string is not the string that contains one space. It's the string that contains no characters at all. If different than null, it's different than a space, right? Does this make sense? Now, in this case, right, if it's not empty, what do we return? Well, if we could reverse the rest of the string, right, then what can we do with the first character? Imagine that you have A, B, C, D, right? You're going to get the first character, which is A, and then B, C, D. B, C, D gets reversed, so it's D, C, B. Then what do you need to do with that A to return A, B, C, D reversed? You have A, B, C, D, right? Rev B, C, D, which is C, D, C, B, right? And then what do you do to D, C, B and A to get A, B, C, D reversed? What do you need to do? Yeah. Stick them together, right?
And then reverse?
No, that's already reversed. A, B, C, D, D, C, B, A. Does that make sense? Does this idea make sense? So how do we represent this? So if it wasn't empty, what do we return? How can I reverse the rest of the string? I call reverse on tail of S, right? Does this make sense? Yes, no, maybe. So what do we expect to get? DC, DBA, and nitro 1, right? Yay! Isn't this cool? Isn't recursion cool? Yes, you should be saying yes!
But until we don't understand.
What do you mean? You guys were doing this stuff, right? You guys were telling me what to do.
It takes some time to install it. We have downloaded it.
At first session of data structure. First session.
Yeah, so hopefully by now you know it, right?
No, it
So
was
they
freaking
know it.
hard.
What about us?
It takes a while to get used to it, right? If you think about it, we use recursion all the time in real life, right? Do you see where we use recursion? In computers, where do we use recursion? What happens when you look at your file thingy, right? What do you have here? Folders, right? And each one of these folders has more folders and more folders until you get really tired. What is this? Recursion, right? Who is your boss at work? Who can give you orders? Well, my boss, and then who else?
His boss.
Their boss, and their boss, and their boss, right? It's recursion, right? Who do I need to make happy? My boss and his boss, or their boss, and, right? All the way up, right? His bosses all the way down. Who are my ancestors? My parents and their parents and their parents, right? It's recursion, right? Many times we name the levels, but how do we divide the country? Well, into states and then counties and then cities, right? So we tend to have this kind of stuff all over. It's not that weird.
That's the reason I don't understand this one. I had other code to reverse the string, which that wasn't like that. That's the reason I'm a bit confused. You just use the reverse, you just call it and it gives you the answer. It's pretty easy.
Wait, what you're saying is there is already a string method on the string class that reverses the string.
I think it does the same thing that you did too.
Yes, but yours is pretty easy, but it's a bit confusing because you didn't do anything with s length or something.
We are, except that we are hiding it.
Yeah,
It's empty, right?
Yeah.
Uses s length. Tail uses s length, right? To find out where, except that we just hid it. We can do it.
So actually, you want to teach us we can we can divide the process in tail, head, and different functions and call them together.
Yes. Yes. It's more examples. We can. Let's do reverse by counting, right?
Yeah.
Let's do it by counting and see how it would look like, right? Let me call it Rev C. You're not using a string buffer or anything like that, right? So we have to basically do the same thing. What we need is, right? I think this is what we did last class, no? Not here. So this is the reverse of a string from a given character, right? Starting at a given point, right? So we can check if from is greater than s dot length, right? If not, that, yeah. This should work, right? Maybe, or blow up. Murphy's law says that whenever I'm doing something, right, whenever you're giving a demo, it has to blow up. Oops, I need to start passing stuff here. Okay. Yeah, it did not blow up. Is that what you had done? Something like that, right? And once you do that, you normally build a wrapper. So that the other guys can call it the same way. If you think about it, this is reasonably similar to what we normally. This is reasonably the same to what we do with ints. In a way, when we count and things like that with recursion, we are thinking of integers as 0 and then adding 1. And that you can generate all the integers that way, right? 0, 0 plus 1 is 1, 1 plus 1 is 2, 3, right? That's counting, right? Adding 1 to the previous number. So that's how we do our recursion. In this case, we were counting from 0 all the way to here, right? But do it the other way, it would probably be hard. Many times we can count either up or down. And I'm not seeing how to count down. So we had stuff like how can we print all the numbers, right? Actually, let me do this, because that would allow us to do nice stuff. How can we print numbers from low to high? And we are gonna include them, right? So we're gonna print both low and high, right? How do we know that we are done? Low is actually greater than high, right? Because right? If it's equal, we still want to print low or high, right? So if low greater than high, we just return and do nothing, right? Otherwise, what do we do? I need to do something with this guy first, probably, right? I want to print the number, right? Which number? And then print count up, out, low, plus 1, high. Does this make sense? And we can do cool stuff. That's cool, right? What happens if I do this? Do you think this would work? I just moved, right, the recursive call above the printing of this current guy. Would that work?
Would it just like print 5?
It would print 5, and then 4, and then 3. It would print them in reverse. Because I first go towards the end, right? Eventually it gets to 5, prints 5, then prints 4, then prints 3, then prints 2. Does that make sense? So the order is definitely important. So this is actually print count down rather than up.
So let's say, from the previous class, if we write it print down from, and we change the order, it will count 1 to 5?
Probably, yes. We would need the actual code, right? So, but probably yes. In fact,
Yes.
yeah, it is basically the same stuff. Die. Die, you thingy. So instead of print count up, if I do wait, in this case, from was supposed to be high or low? High, right? From is low. No, from is high, right? Yeah. Just to put it in the same terms, right? If we do it like that, it would do 1 through 5, hopefully. Or die. Oh. Yeah. Oh, because I'm putting low first and high. I so I need to pass 5 and 1. Or actually, let me leave it like that. Just change the order. No, but I need to do it here, because if not, I'm messing things up. So I need low and high minus 1, right? It's almost the same. When I run it, I get 5, 4, 3, 2, because we are not doing, right? Here we are stopping when they are equal. Here we are not. So if we were to change this, now we would get 5, 4, 3, 2, 1. Then if we were to move this, it actually count up. Right? Let me fix it. What do you need to do when you get home? Do this, do it 5 times. Now count by threes, count, right? Up or down, or only odd numbers, only even numbers. Actually, let's do cool stuff. So, we get an integer, and we want to convert it to a string. Actually, we get an integer and we want to make it into a string with decimals, right? So we get 123 and we want to convert it into this string 1, 2, 3, right? How can we do it? Well, we could do something like this and let Java do its magic, but we are not. We're gonna be masochists and do it, right? A lot of these exercises, somebody has made them, right? There's a library for it, but we are going through how would you do it, right? How could we convert an integer to a string? I can do it kind of the reverse. How can we get the last digit of an integer? You have 123, how can you get 3? Yes, modulo 10, right? Does that make sense? Right? So 123 modulo 10 is 3. Does that make sense? Yes? How can we get the first digits? Every digit but the last one. So if I have 123, I want to get 12. Does that make sense? How do I do that?
We have what? Sorry?
123 and I want 12. I want to eliminate the last digit, right? Kind of shift my number 1 digit to the right. It's close to the one above, right? Sorry? Yes, divide by 10, right? And it truncates. Does this idea make sense? We haven't done any recursion yet, so we can do let me do this so it stops bugging me and make this thing static, right? Perfect. Should be first digit, right? Oh, first digits because it's everyone but the last one, right? So 123. And then what do we expect to get? 12, 1, 2, 3, 4, 3, and 7, right? If that stuff actually works. Yay! Right? Now, how can I use that to convert a number into a string? If the number is 0, the empty string. Does that make sense? If not, what do I do? Int to decimal string of first digits of n, right? Plus, but now this is a digit, right? This is actually a number, right? But I want to make it a character. Sorry? 0 is a character, right? If I have the number, the integer 0, this would return the character 0. If I have the number 1, this would return the character 1. I'm assuming that the characters from 0 through 9 are consecutively as characters, which they are in every sane system. Does that idea make sense? The integer 0 is not the character 0, right? The ASCII value of the character 0 is 48, maybe? We don't use 0 to represent 0. Right? No? Maybe? We have talked a little bit about ASCII and about hex, right? Unicode and that kind of stuff, right? So the character for the digit 0 is, where is it? Oh, 48. Woohoo! My ability to memorize random manure is still good. There's no particular reason why you would know that, right? But which is why we do character 0. With some luck, this would actually work. We are not using it, but static. Oops. Sometimes what's happening is that this stuff is an int. So it actually added 51, which is 3. So we need to make sure that that's a car. Yay! Isn't this cool? Sorry? It was considering this as an integer, converting it to a string and then concatenating. So instead of the digit 3, it was doing 51, which is the ASCII code of the digit 3, but it was doing a 5 and a 1 instead of a 3. Maybe we should do car int 2 digit. Maybe this will make it subclass, right? Static. Oh, it's telling me that I'm returning an int. Yes. Cast car. So this makes it less horrible. Can we do it? Well, just so you know, there's only one slightly horrible thing, which in a reasonable thing would actually make a wrapper. Because if you pass 0, you're going to get the empty string as opposed to 0. 0 is a special case in this case. But let's assume that that's okay. Can we do it with binary? We would need to do something like this. How do I get the last bit of a number? It was written in binary, right? How do I get the last bit? What is the last bit of a number?
If it's even or odd.
If it's even or odd, right? So what can I do? Modulo 2, right? And how do I get the first bits? All but the last one. Divide by 2, right? And that shifts. Does that make sense? That's because integer division truncates. Does this make sense? So that basically allows me to just replace this . What happens if we do 123? I have no clue what the bit pattern is, right? Do you remember any bit pattern? If we use powers of 2, what happens? What's the number 2 in binary? 1, 0, right? The number 4,
1, 0,
1, 0, 0, right? So if we use powers of 2, we get a 1 and a bunch of zeros, right? If we use powers of 2 minus 1, what do we get? A bunch of 1s, right? So we could do 128, and that would give me a 1 and a bunch of zeros. Or I could do 127, and that would give me a bunch of 1s. How many zeros in 128? A 1 and how many zeros? 7. It's not terribly useful, but when you have a chance, go memorize powers of 2. It is something that is not, right? No class will make you memorize them, but it's very, very useful to have them in your mind. You probably want to make sure that you memorize 256, which is 8 bits, 1 byte, because we do by 8. You probably want to make sure that you memorize 1024, which is 2 to the 10, because it's very close to 1,000, so it allows you to make rough conversions with binary. And you kind of, if you just go when you have a chance, when you're driving, when you're waiting in line or something like that, just go 2, 4, 8, 16, right? So that you have them fresh on your brain. So this will be a 1 and 7 zeros. This will be 7 1s, right? If we did it the right way. Yay! 1, 2, 3, 4, 5, 6, 7. Is this cool or what? What? Okay. I can't detect that much excitement now. Yeah. Should we try the other way around? Actually, when you have a chance at home, convert this into one where you pass the base. So you can go to hex, to octal, to whatever, right? And go play with those things. It's not a bad idea to have a clue about octal and binary and hex and those things. You will be tortured a little bit with those things when you do computer architecture. But it's a good idea to get, the more practice you get, the easier it's going to be. It's not something that you use every day, but it's something that's always kind of around there. It'll probably even work for hex. What else would be cool? Sorry? Power? Okay, we have done power, but we can do it again, right? No, it's okay. We did power. But base exponent, right? We can do it again. It's not a bad idea to do a bunch, right? What happens when we do power? If the exponent is 0, right? That's your easiest case, right? Your base case. What do? Whatever raised to the 0th power is 1, right? So if exponent is 0, else what do we return? Our base exponent minus 1, right? Times base. Or I tend to do it the other way around. Does this make sense? 2 to the 8 power, and that should get us what? Sorry? 2 to the 8 is 256, right? Is one of those that you should memorize. Does this make sense? Those are cool examples that we have. I lost track. I was gonna do something cool, maybe. What would be cool that we can do with recursion? Sorry? Oh, GCD. We can do GCD, but nah, you can find the example there. I was gonna do the one that we didn't do, because it's interesting. The other standard example. Fibonacci numbers, right? They are actually a lot of fun when you're bored. You start with 1. Actually, it depends on how you define them. You can start with 0 and 1, right? And then you keep adding the previous 2 numbers, right? So 0 and 1, the next number is going to be 1, right? Then the next number is going to be 2, 1 plus 1, then 3, then 5, then 8, 13, 21. Does that make sense? So you do 0, 1, 1, 0, 1, right? And then the next one is, this is 1 plus 1, so it's 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, 8 plus 5 is 13, 21, 34, 55, and so on. Does that idea make sense? You are familiar with this sequence. They tortured you with this at some point in time in your career, right? This asks for the nth number in this sequence. Does that make sense? What's our easy number? Our easy cases. We know these two, right? So if n is 0, what do we return? Right, so if it's 0, I'm going to return 0, that's this case. If it's 1, I'm going to return 1, that's this case, right? But if it's somewhere in here, if it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? How can I calculate this guy? Fibonacci of 10. It's going to be what? The sum of the previous two, right? Does this make sense? If you want to find this guy, right, you do it by adding this and this, right? That's how so Fibonacci of 10 is Fibonacci of 9 plus Fibonacci of 8, right? And so Fibonacci of n is Fibonacci of n minus 1 plus Fibonacci of n minus 2. N is kind of an index into this sequence. Does that make sense?
So we already assumed Fibonacci, our function Fibonacci, it already knows how to calculate the previous.
Yes.
So you did it before, or?
No, I'm doing it right here. It knows how to calculate it, right? calculates it by either, if it's 0, then it knows it. If it's 1, it knows it. And if not, it's going to calculate it. Yes, no, maybe. This is how we do recursion, right? Some people have called this the leap of faith, right? You call your own function that you haven't quite finished, right? But you trust that since you're defining it the right way, it's going to work, right? You're calling the function and you haven't kind of finished defining it, right? But by defining all the cases, it works. Does that idea make sense? We have been doing this all over, right? Here, I'm calling this guy and I haven't quite defined this guy, right? And I'm probably misspelling Fibonacci. He's Italian. What did you expect? So 10 should be 55, right? Unless I don't know how to count, and then it's 34 or 21 or 1 of those. 55. I know how to count. Woohoo! There is a problem with this definition of Fibonacci, right? What's the problem with it? Imagine that I'm doing Fibonacci of 10, right? It's going to be what? 9 plus, right? In order to calculate Fib of 9, what do I need to get? Right? Then I'm going to calculate Fib of 8 twice, right? Does that make sense? How many times am I calculating Fib of 7? 3 times, right? 1 in here, 1 in here, and 1 in here. Does that make sense? So this function is quadratic. Does that idea make sense? If I'm calculating Fib of 10, it's not going to take me 10 steps. It's going to take me 100 steps. So if I do Fibonacci of 1,000, shouldn't break my thing, but it should take noticeably time. It's taking about 1,000,000 steps. I think it's not exponential, it's just quadratic. This is too long. Alright, so let's do 100. That should be doable, right? God, it's still a lot.
Is there any computer that can solve this one in a second or something? Is that to the computer?
I have no clue. What you do if you don't compute it this way, right? What you normally want to do is to store those things so you don't end up doing the same thing, doing wasted effort, right? You don't calculate people of 8, 10 times. Right?
Is it because of the computer?
No, it's because of how we are calculating it. We are calling Fibonacci of n minus 1 plus Fibonacci of n minus 2, right? So we end up calculating Fibonacci of n minus 2, right, twice, right? One in one direction here and one what we call Fibonacci of n minus 1. Does that make sense? We end up calculating Fibonacci of n minus 3 times. And so on. God, this
Is there an
takes
easy way?
forever. Yeah. We'll see the easy way, which doesn't involve 10 work, right? We had, yeah. So 20 should take, yeah, this is not exponential, yeah. Actually, yeah. We can do this. So we can do 10, 20. We are printing the number of that's the number of milliseconds. So we can do 40 and 80. That is not, that's, yeah. This one was less than 1 millisecond. This one is 2, right? But then this one took 10 or 11 milliseconds. This is supposed to be quadratic, not exponential. So we are probably hitting some weird nonlinear stuff where we lower cache or something like that, and then stuff starts becoming much, much slower. I think our stack space is also quadratic. So performance, when you do it this way, sucks. Don't do it this way. Cool. I think we have done a gajillion examples of recursion, right? You should be definitely able to do recursion on numbers, right? To count and things like that. And we have the assignment has 4 or 5 simple things that you do with recursion. Some of them are counting, some of them are similar to power, things like that. I will post this lecture, and I think yesterday's is already